two. Christina and somebody else. Sorry. Anyway, here we go. So we have this imaginary number. It's an I, and that's why when we're setting up equations, we typically won't use I as a variable because I has its own distinct use. And that means it's equal to the square root of -1. And an I is what's called an imaginary unit. When you combine it with some real parts, you get what's called a complex number. Complex numbers, by the way, we'll get to this a little later on. They like to work in pairs. We'll talk about that later. All right, so in this 2 plus 3i complex number, 2 and 3 are real parts, and I is your imaginary part. And this is what we refer to as standard form. Standard form is, in general, a plus or minus bi, and we will write our answers in standard form. A plus or minus bi. The addition and subtraction part of complex numbers is just like combining like terms, so that's not a big deal. The multiplication part of it, really not a big deal because that's like, well, then I have binomials and binomials. It's just like FOIL. Not bad. Division, though, we got to be careful with division because division, we have to get rid of any complex parts or imaginary parts that are in a denominator. We don't like imaginaries hanging out in the denominator, just like we don't like square roots or cube roots or any other kind of root hanging out in the denominator. So we rationalize them. And when we do that with complex numbers, we do it through what's called a conjugate. Do you guys remember? Does that sound familiar to you, conjugate? Mm-hmm. Yeah, conjugates, yeah, we're going to use those. Okay, so let's do this addition, subtraction part. Just dealing with combining like terms. And of course, it's always that dreaded negative sign hanging out in front of a complex number that we forget to do what with it? We forget to distribute it. And it changes the real parts of your complex number. So you have to be careful with the negatives, the distribution of those negatives when you're doing subtraction. Addition, and not so bad. So, 2 real part, 6 real part, both of them constants. And then we have some imaginary components. We have minus 3i and plus 3 or 2i. So those are my like terms. Those are my constants. These are my variable terms there that we're going to combine. And this just becomes a new complex number of 8 minus 5. Just add them up. No, not much more in the way of complicated than that. Just put the real part at the beginning and then your imaginary parts at the beginning. 8 minus 5. We're going to kind of jump around here a little bit. We're not going to hit all of these. The discussion of that negative, this is saying the opposite of the complex number positive 4 minus 5i, or just think about distribute. So the opposite of a 4 minus 5i would become a negative 4 plus 5i. And that's the part we have to be careful with, is the distribution. So going down to the problem below, where I have the 2 complex numbers that you're subtracting one from the other. That's where I have to be careful. Now notice that parentheses are around 7 minus 3i and 6 plus 2i. Don't forget your parentheses around complex numbers. If you don't put them there, then it can easily be lost or misinterpreted that it's not even a complex number. So put the parentheses around the a and the bi parts to kind of keep them separated. All right, what's my answer on that? On this one right here. What am I going to get? 1 minus 5i? Okay. I like that. just the inflection of my voice causes you to be a little disturbed, right? You were correct in your first answer, so be confident. Good, man. Minus 5i, that's right. Distribute that, becomes a negative 2i. So I have 1 because of 7 minus 6. So sometimes you can do it like this. You can kind of separate it if you need to into the real parts. And then we have a negative 3i minus a 2i. There's the imaginary parts. Giving me 1 minus 5i. There we go. 1 minus 5i. Distribution, distribution, distribution. Always, 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 always. Have that negative sign in front of a parenthesis. Remember, you got to. You're all right over here talking to yourself. Okay. Multiplying. Stop me if you guys have any questions, all right? We're going to kind of fly through this hope pretty quickly because, again, I think it's going to be review for us. So multiplying, distribution, foiling, if it's a binomial times a binomial. The only thing we got to be careful with when we're distributing is that I squareds, they become something else. They morph and become what? Negative 1. Hey, that was a pretty good response. That's a little better, a little more on the lively side, guys. Way to go. So if we distribute this, we got our real parts, 2 and 6. There's my 12. And then if I'm going to do that whole FOIL thing, I got 2 and a 2i. That means I have a 4i. Then I've got a negative 3i and a 6. There's negative 18 i's. Negative 3i, positive 2, negative 6i squared. So this is where you pull out your sword and you pierce the I squared. And you make it become a negative 1. So I squared becomes negative 1. Just do that. Every time you get an I squared, pierce it with the sword, make it a negative 1. Now you have a negative 1 times a negative 6, or positive 6. All right. So now I have 12 plus 4i minus 18i, so that's 12 minus 14i's plus 6. 12 and 6, 18 minus 14i, and you have your new complex number. So let's talk about the kind of answers we could get when I multiply complex numbers together with real parts or another complex number. Here's one of the answers I could get. Another complex number. Look at that. You could also have situations like in the one below it. 4 minus 5i and 4 plus 5i. Does anyone recognize that as something special we've worked with before? Christy, do you recognize that? What is it called? You do? Is it called something that has the word difference in it? And has the word 2 in it? And then has the word squares in it? Yeah, a difference of 2 squared. That would be a difference of 2 squared right there. So here we get a situation where I take 2 complex numbers and they produce a real number. Look at that. How does that happen? Well, the i's are going to cancel each other, and I will not have any i's, no imaginary parts in here. So foiling, 16, and then we have negative and positive 20i. Right? There's 20 i's, there's negative 20 i's, which they cancel each other. And then we get negative 25i squared, and we pierce I squared and make it a negative 1. And now I have 16 plus 25. 41. So look at that. So we could get a real solution if we multiply 2 complex numbers together. So our i's could actually disappear. Yes?
On the second one?
Yes, on this one over here, the I plus, yeah.
It comes out to negative 5i minus 4.
Yeah.
You have to write it as negative 4 minus 4.
Negative 5i plus 4i squared.
Yeah, there you go.
Right? So negative 5i write it that way. Standard form puts the real part in front, the imaginary part after it. So we rearrange this, right? And we rearrange. Remember, the sign in front of a number goes with it. So this is actually negative 4 minus 5. So stick the imaginaries at the tail end of your complex number. No questions? We're still good? All right, why don't you guys try here for me? A 7 minus 3i, 6 plus 2i. This one, the 7 minus 3i and 6 plus 2i. Simon, let's go, wake up.
I know it's my smooth sultry voice just puts you to sleep, doesn't it? That's right, Simon. You're under my control.
Let's go. Okay, we're going to use Gurab here. See if he's got the right answer. I'll wait a couple more seconds for people to come up with something. But we're going to assume that this is right. We ready? Still going? All right, we're done. He has 36 minus 4i. What do you have? Anyone have anything different than 36 minus 4i? What do you have, Jake?
48.
48?
48 minus 1.
48 minus 4i? All right, let's see what happened here. So 7 and 6 is 42. And 7 and 2i is 14 i's. And 3i, negative 3i and 6 is negative 18 i's. And negative 3i and 2i is negative 6i squared. So we pierce it, make it a negative 1. We get 42 minus 4i's plus 6. 48 minus 4. All right. There we go. Okay, what if you just have all these imaginary parts multiplying together? Right? You just have the i's and the i's and the i's. It's our I rule, right? Our I rule is going to come into play. Well, our I squared rule is going to come into play. Yeah. But what if it's like a bigger power? If you have I to the third, I to the fourth, or any other I to the power. There's a pattern. Yeah, we're going to get to the pattern here in just a second. All right, I'm going to fix it. You'll see just reverse. What's this going to be? Negative 5i, 4i is going to be what?
Negative 29 squared.
And then
20.
20. This is a real number, negative 20i squared. I squared becomes negative 1. Negative 1 times negative 20. All right, over here, the 4i, 2i, 3i, are we going to have any i's in this answer? Yes, we are. Because now you get an I cubed. So here's what you can do. There's a couple different ways we can tackle this one. So all of the coefficients are going to multiply. We get 4 times 2 times 3, we get 24. Right? 24. Then I have an I times an I times I, which is a 24i cubed. So maybe you do this, and then I'll show you the pattern just afterwards. So maybe you look at this and you go, I don't know I cubes, but I do know that I squared times I to the firsts make I cubes. And an I squared we can pierce and make a negative 1 out of it. And now I really have a negative 24 times an I. And that's as far as we can go. Negative 24i. So here's the pattern you have. We actually have 4 different patterns you can look for when you're working with i's. I to the first, I squared, I to the third, and I to the fourth. Each of them have a distinct answer. I is just I. But I squared, well, we know that's already negative 1. But look what I cubed is. I cubed is I squared times I, which we just did that, right? Negative 1 times I. And I to the fourth is I squared squared. There's our power property right there. Power properties of exponents. And if I squared is negative 1 and we square it, we get a 1. So now what you can do with these is you can use these 4 rules, I squared, I cubed, I fourth, and help me simplify some answers when I have I to a multiple power. You need to go take a lap. No, please go take a lap. Come on. No, I can sympathize. I've been in that chair. All right. So what do when we have these higher powers? Let's see if we can use our patterns and quickly come up with an answer. You guys ready? This is the challenge right here. This is the challenge of the day. All right, here we go. We'll start out with some simple ones. I to the 8th. What's the answer? Look at that. How did you do it? Now, there's going to be different, people are going to do it different ways, but like, so you said your answer pretty quickly, Matthew. How did you get 1? You divide it by 4?
Like, what units, I to the 8th, it's like I to the 4th times.
Yeah. So I to the 8th, did you hear what he said? So he said I to the 8th. I to the 8th is I to the, did you say I to the 4th times 2? All right.
I to the 4th.
I to the 4th, I to the 4th, 4, I to the 4th squared. Right? Right. So we know I to the 4th, based on our last rule, is 1. And 1 squared is 1. Did anyone do it differently than that? Perhaps using the, what did you use?
Wouldn't it be if it's an even number?
Be careful with that. If it's an even number, is it a 1? Let's look at, that's a great feed into this next one. Thank you very much. What is I to the 6th? Now that's an even number, right? And I got a 1 out of that, but what's I to the 6th? So they're saying it's going to become a negative. So can I use the rule that if it's an even power, I always get a 1? Well, I to the 6th is I squared cubed, or, look at it this way, it's I cubed squared. And we know I cubed was equal to what? What was I cubed, guys? Negative I. I cubed is negative I. And by squaring negative I get a what? What? What do I get there? Positive 1 or negative 1? Don't I get this? Don't I get that? So I can't just say every even number is going to become. It depends. It really depends on your 4 conditions. Your I to the 2nd, I to the 3rd, and I to the 4th. Okay? So you're going to have to decide what do you want to do. If I have a power that's divisible by 3, I know I'm going to always get that negative in there. If I have a power that's divisible by 2, I'm going to have an I squared negative 1 thing going on. I to the 4th, that's something divisible by 4, I'm always going to get a 1 in there. Or you could always take the simplified approach of how many I squareds are in that power. Every I squared, right, becomes a negative 1. And then I can work it out back. So there's a couple different solutions. Let's do a couple that are larger numbers so we can get some practice with this. Well, maybe I should. Are there questions, first of all, on why I to the 8th, I to the 6th? Okay, again, it's going back to, no, not that. It's going to here. If I can remember this stuff right here, it might be helpful. All right, let's try some. Oh, wait, there we were, right there. So let's try this I to the, so here's some examples of I to the 25th. This is the example where I'm considering how many squares go into the number. So basically you say, take that number, divide it by 2, and whatever the leftovers are, that becomes an I. So 25 divided by 2 gives me 12 of them, and I have 1 I that's left over. So I squared to the 12th power becomes negative 1 to the 12th power, which becomes 1. And then I have an I left over, so I have I as I to the 25th. There's an example of 24th power. We just did that one. I squared to the 12th power becomes 1. So this is just considering how many I squareds are going into that power. Basically divide the power by 2 and you'll always have 1 left over. Every time. Alright, why don't you guys knock those 2 out for me real quick. I to the 34th and I to the 35th. What am I going to get? Okay, let's see here. Mr. Alex. I to the 30. Negative 1. You're pretty confident about that. How'd you do it?
Since 34 isn't I divided 34 by 2, 17.
So you took 34 divided by 2 and you got 17 of them.
Yeah.
Yep. So I squared to the 17th power, that becomes negative 1 to the 17th power. Anytime I have a negative raised to an odd power, I will say negative. Very good. Yeah? Who has I to the 35th? Yes? Negative I. We already have I to the 34th, right? So let's just add an I. Or not add, multiply by. If this is I to the 34th, then we have to just have another I to the first, so we get negative 1 times I, or just negative I. All right, so it doesn't matter how big the power is. I can very quickly determine what I'm going to get for this one. How we doing, peeps? Any questions so far? Take a little break. Stretch break. Quotient, median, division. So here's where you got to be careful. Don't want those i's hanging out in the denominator. We get rid of them by using conjugates. When you're ready, sign. Okay. So when you are using a plus bi as your denominator, that means you're going to multiply by a conjugate. Can somebody describe the conjugate of a plus bi? A minus bi, very good. So when it's a complex number, I'm going to use the opposite sign value. What if it's just a 2i? Now how do I deal with getting rid of those i's down there? Well, there's actually a few things I could do. What's something somebody might consider doing if I have a 1 divided by a 2i? What might you just maybe say, I'm just going to do this. Multiply by 2i on the top and bottom. Oh, okay, we're saying use a negative 2i. Remember, the goal is to get i's to become I squared, so that become negative 1. So I really don't need to think of an opposite on that case, because it's not paired with a real part. So for this 1 over 2i, I could get away with just multiplying by an I. I don't need a negative I, because 2i is not a complex number with the real part, constant real part, right? That's a 0 right now. The a part is a 0. And so if I don't have the a plus bi form, I don't need to think about a conjugate. I can just simply make i's become I squareds, and then this becomes I, 2i squareds, I pierce the I squared over negative, or negative I over 2. No more i's in the denominator. It's okay that they hang out in the numerator. They're legal there. So we would be good. The others, be honest with me, was somebody thinking about multiplying by 2i? Anyone think about doing that? Because that would be okay. You could still do that. Watch what happens if you multiply by a 2i. You're just going to end up simplifying down to the answer we have over there. So a 2i, and we say, all right, we're going to multiply 2i on the top and the bottom. That gives me a 2i over a 4i squared, which gives me a 2i over a negative 4, which reduces to a negative I over 2. So I'd still get the same answer. use the coefficient in front of the I. But, now we think about the conjugate. There it is, our friend the conjugate. Now I've asked everybody, well not everybody, I've asked a lot of my classes, you know, when you get older and you have a family and you have kids, why don't you consider them naming them conjugates? Wouldn't they? Especially if you have two. One of them can be complex, the other one can be complex. It would be unique, right? Aren't we like trying to be unique? You name your kids names that are kind of sometimes unique. Do you agree with me? Or am I just like barking up the wrong tree right now? You wouldn't do conjugates? Apple, yes. Yeah, that would be the dude, the lead singer for Coldplay, Chris Martin's daughter. Yeah, Apple. Their son's name is Banana. No, really not Banana. Juice. This is apple juice. All right. Yeah. Apple's not a weird name. Is that a weird name? Apple. Okay. All right. Just check that. I don't know. I don't know if apple's all that. Well then. Moving on. Here we go. So conjugates. We got this conjugate A plus a BI. We just said a little while ago that a conjugate would be A minus BI. So we're going to get that 2 plus 3i. We want that to become down there a whole number or an integer so that there's no I involved. So we just multiply the numerator and the denominator. So everything. Now why am I having to do this? Why do I have to do both numerator and denominator? Oops. By 2 minus 3i. Can somebody explain that? Okay, so the first reason we're doing this is to get rid of the I in the denominator. But let's back up even further. Can't cross out a plus or minus. Okay, you mean you're looking at it as a factor thing, right? Yeah. Here's another reason. If I change the problem by multiplying by the same thing over the same thing, that's why. It's a 1, so I have to change the problem. So we're going to get 2 minus 3i